The best thing to do here to build our understanding of these problems is to work with some examples. So first, let's think about a case where what we want to do is have you and 11 of your friends decide to form a club where the group needs to choose 3 officers, a president, a vice president, and a treasurer. And we want to determine how many ways those 3 offices can be filled. So here, what we have to understand is that one person cannot simultaneously fill 2 roles. So every time you select one person to fill a role, you've got less options for the others as well as less roles to fill. And also, with these, the order in which the roles are filled does kind of matter, because president is presumably a different job from vice president, which is presumably a different job from treasurer. So we will be using permutations here, where we have n equals 12 people in the club, you and your 11 friends, and R is for our 3 offices, the president, vice president, and treasurer. And what we're going to do is permute these 3 roles from the 12 people. So, in terms of that notation, we get something of form 12 factorial divided by 12 minus 3 quantity factorial. Where what we can do then is take that subtraction and get 12 factorial over 9 factorial, because we're selecting the 3 of them, and then the other 9 don't really get much of an order within the club. So we can multiply out a little bit and write this as 12 times 11 times 10 times 9 factorial over 9 factorial, which would really just be 12 times 11 times 10, as those 9 factorials will cancel out, leaving us with a total value of 1,320. For our second example, what we want to do is find the number of ways of forming 4-digit codes in which no digit is repeated. So what we have to do here is again understand that for each of the digits, we've got 10 possibilities, 0 through 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here, the order will also matter, because a code of 1, 2, 3, 4 is different from 2, 1, 3, 4. Hopefully, anyway, otherwise we wouldn't have a whole lot to work with as far as combinations, although that is sort of a pun we'll see later. But anyway, we are again going to use permutations, where we have n equals 10 options, the 10 digits, and we're selecting specifically r equals 4 of them, so we are permuting 4 options from 10, which means we're looking at performing a computation of form 10 factorial over 10 minus 4 factorial. And I'll say that for dealing with this, we can also run this on at least certain kinds of calculators to get this value maybe a touch quicker, especially as we're seeing more and more of these. But for now, I am going to go through how to do this by hand just to be sure. So what we could do is take that value and subtract out the 4 to get 6 factorial down there on the bottom, and then we can cancel out a 9, 8, 7, 6 factorial, and be left with 10 times 9 times 8 times 7, which multiplies out to 5,040, which tells us that we get 5,040 total ways to select the 4-digit code.